Assalamualaikum everyone. In this video tutorial, I will show you how to do the tutorial for electronic cooling. So please open the file that I have shared within the Microsoft Teams. And when you open the file, you will see something like this. This is an electronic device with a PCB board and it is enclosed in a casing. So if I turn around the view, you can see there is a fan at the back of the casing and there are multiple components inside of the casing, and you can also see at the other end of the casing is a wall equipped or features with multiple small holes. I believe everyone knows that the function of the fan is to pull cold air from outside, take it inside of the casing and push the hot air throughout the small hole at the end. In this video tutorial, I will show you on how to set up the parameter or the setting so that we can do simulation on electronic cooling. However, to do that, please make sure you are on the mode simulation, which is by default when you open this file. And when you want to edit or you want to put the certain parameters, you have to hide the casing first. So click on the casing, and when you see when the casing turn blue, you can also check on the tree on the left. On the tree on the left, there is this short dotted blue line appear on simulation model 5. So meaning that the object that we have selected is somehow over here. So open the tree. So open the model component and then open the bodies. And this is the thing that we want to hide. So click this eye over here to hide the casing. So now you can have access to all of the component inside. So the option for electronic cooling, you can include what kind of a component that will be producing heat and what kind of component that are responsible to remove the heat. So let's start with the component that will produce heat. So before we start, we also need to remove this heat sink. So click on this one, and when you click, please take note that there is the dotted blue line appear on the model component and it is appear on the simple heat sink. So click to make the heat sink disappear for a while, because we want to have access to the component under the heat sink. So go to loads and select thermal load and select on this transistor over here or the chip and use 5 watts. Select OK. So when you have applied the heat load, you can see the sign or the symbol appearing on top of that component. So repeat the same step again. Click loads and select these two components, and the heat produced or heat load is 0.1 only. Select OK. Repeat again, this time for the transistor, all 4 of them, and the value is 0.2. Select OK. Then again, select on the small transistor, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. The value of this one, I think, should be around 0.1 watt only. And the last 4, 1, 2, 3, 4, this is 0.05. And select OK. Now we have applied heat loads to all of the components that we believe will produce heat. So now we want to assign the component that are responsible to remove heat. So select the heat sink to make it appear again. and select cooling, go to heatsink and select this one and select OK. And then another component, fan. Select the fan, and you can see the arrow is moving on the wrong side, going outside. So click flip direction so that the arrow or the wind flow is moving inside to the component. And the flow rate, change it to 2 cmh and select OK. So now we have completed assigning all the heat loads and cooling, and select on threshold. In the threshold for this component, if you are working in the industry, you can select which type of component and what are their maximum allowable temperature. This will help us or engineer to know during this simulation which component the temperature will reach the maximum, so that we know that temperature or that particular component most likely to fail during operation. So this one, in this case, it is already stated 85 degrees Celsius and some of the component is 100 degree. So just select OK, no need to change anything. And then just to make the casing appear again, so select pre-check. The study setup has all the information required, and then you can solve the study. I have made several separate exercise. This one, however, the simulation will take quite a long time because there are too many calculation involved, and this has been around a few hours, I think 1 hour. So this is something that you may want to check later on. What I would want to know for this tutorial, how will the flow of heat or the flow of air is going to be when it's coming in from outside to inside. And I think that's all for the tutorial today. So thank you very much. I will not be showing the final simulation, the final output, because my example myself is still undergo the calculation. So this one will take a while. So I think that's all for today's tutorial. Thank you everyone.